We're going to prove the law of cosines. Here's your diagram. Opposite angle C is side C, little c. Opposite angle B is little b, and opposite angle A is little a, side little a. Now, in this case, we drop a perpendicular from angle B, which falls inside of in the interior of the triangle. Now, what we have here is this would be x. This would be x. And if this, we'll call this point D, this is going to be b minus x. Now, the height of the altitude is h. BD is your perpendicular, which is your altitude. The altitude has height h. What we want to do now is relate these variables. So we rely on the Pythagorean theorem, of course, because Pythagorean theorem is a special case of this of the law of cosines. So we know that the x squared plus h squared is equal to a squared, because in the triangle on the left, the right triangle on the left. Now we look at the right triangle on the right, and we get b minus x all squared plus h squared is going to be c squared. Now we subtract these equals. Subtracted from equals, the differences are equal. So when we subtract, we have this. Now we subtracted, so we get this. We're subtracting here. Subtracting the bottom equation from the top equation. Now what is this telling us? This is telling us that x squared minus, now b minus x all squared here is b squared minus 2bx plus x squared this would be your FOIL, first inside, outside, last. Because what is it we have here? We have b minus x times b minus x. I go first, outer, inner, last, which gives you this. Now these is being subtracted, so these cancel out, and we arrange the situation so that we put these two terms on the right side of the equation. We push them to the right, and we push this c squared, the minus c squared, to the left. We get a c squared is equal to a squared. Now we're subtracting, so we add now because we're subtracting b squared on this side, so when we push it over on the right side, we're adding. Now this is a minus gives a plus for reasons we'd best not discuss. So when it goes over here, it becomes minus 2bx. But if we look back at the triangle, this angle C, okay, has a cosine adjacent over hypotenuse. So now x is a cosine C, a cosine C. So we put substitute that for x. We had to get rid of x because x wasn't really part of it wasn't a side of the triangle. Put the x in, you get a cosine C, so you have 2 a b cosine C. 2ab cosine C, which is your law of cosines. That's your law of cosines. But that's only when the angle C is an acute angle. So we need to look at case 1b, and 1b is a little different. So here the altitude fell in the interior of the triangle. But it's possible that the altitude might not fall in the interior of the triangle. So we draw another diagram. And in this diagram, the altitude you're dropping an altitude from B when you drop that altitude from B, this guy is still H. This is still C, the side opposite C. This is A, and this is B. And again, this must be X. Who knows what that is? So what we want to say here is that take the big triangle, the two put together, the triangles put together, we're going to get h squared plus b plus x. This would be the base of the one of the legs of the large right triangle is equal to a squared. And now we look at the little red triangle on the right, and we get h squared plus x squared. That's going to be c squared. This is the case where angle C is still acute, but the altitude falls outside the triangle. Now we subtract to eliminate the h's, get b plus x quantity squared minus x squared equals a squared minus c squared. Now we use FOIL here, we get b squared plus 2bx plus x squared minus x squared equals a squared minus c squared. However, these x's do cancel. We get b squared plus 2bx equals a squared minus c squared. Well, but the cosine of c again is b plus x over a. That when you solve for x here, you get x, multiply both sides by a, and subtract b, you get a cosine c minus b. So you have b squared plus 2b a cosine c minus b equals a squared minus c squared. Yeah. So we get b squared plus 2ab cosine c minus, this is your distributive law, 2b squared equals a squared minus c squared. But now this is b squared and minus 2b squared. You get 2ab cosine c minus b squared equals a squared minus c squared. Now we can sort out all these, solve for positive 1c squared, push c squared to this side, push the b squared to the right side, and push the 2ab cosine c, make it a minus when we push it to the right side. Which is your law of cosines. It's your law of cosines. That's your law of cosines right there. Now we move along to the really the other case, which is when angle C is an obtuse angle. So let's look at that case. This is going to be when angle C is obtuse. Here is your angle C now. So this is obtuse. Obtuse means what? Dull. Acute means sharp. So this is a little, doesn't have a sharp point. It has a little duller, maybe. It's the this is your A, and this is your C, and this is your B. We again we drop the altitude. Yeah, the altitude. So we need to extend the base. Drop the altitude from the point vertex B. So this is going to be X. This is your H. This is your H. So now again, we have the this is X plus B on here, this side here, X plus B. So this over here is might be D. So we have H squared plus X squared equals A squared, and we also have in the big triangle, the big right triangle. That was the little red right triangle. Here's the big triangle. You have H squared plus X plus B squared equals C squared. Now we subtract again. When we subtract, we get X squared plus, this squared is going to be X squared plus 2BX plus B squared. When we subtract, we get this. Now we have on the right, we have A squared minus C squared. Now these go cancel when we subtract. You get, there's no X squared left, term left. You get minus 2BX minus B squared equals A squared minus C squared. Now we can sort this out by solving for c squared, positive c squared. Put the c squared on the other side of the equation. Now what we want to do is we have a squared plus b squared plus 2bx. But this is your angle C here, really. We can give it a name like theta for temporarily here. If we look at the red triangle, this is your C, this is your theta. We have that the cosine of theta is equal to adjacent over hypotenuse. So x adjacent over hypotenuse. The hypotenuse is a. So x is going to be a cosine theta. But what is theta? Theta is 180 minus this angle C is the supplement of theta. So we have that x equals a times cosine of 180 minus c, which is your theta. However, there is a double angle formula which could prove some other time, which tells you that this would be a, now this is going to be cosine 180 cosine c plus sine 180 sine of c. But the sine of 180 is 0. The cosine of 180 is minus 1. So it's minus 1 cos a times, so this is going to be minus 1 times a times the cosine of c, which is your x. So we get c squared equals a squared plus b squared. And you have minus 2ab cosine c. And that would be your law of cosines in the case when the angle in the triangle is obtuse. Now we can discuss the very last case where the angle's a right angle. And where the angle would be a right angle, we would have angle C is a right angle. And that's going to be c squared equals a squared plus b squared by Pythagoras. Now, this agrees with the law of cosines, because the law of cosines would be a squared plus b squared minus 2ab cosine of 90. Cosine of 90 is 0. you can see that you have, in an intuitive way, if both of these are 90, this is 0, B is 0. There's nothing left over for B. So the case where angle C is a right angle also agrees with the law of cosines. And so that's the end of this story.